So I'd like to introduce something that I guess I could coin like the eight universe theory, right? So we always think of the speed of light. You know, we call this, I guess, c. We call c like this like extremely high speed of the universe, right? Whatever. Okay, whatever. Blah blah blah. Well, let's just think of it not as like the high speed of the universe, but we'll think of this is actually being the baseline, 0. So this is the speed of the universe, right? And then all mass comes downward from this, and it goes into like negative states. You understand what I'm saying? So everything comes down from this into mass and slows down. So check this out. Here's how I can explain this to you. So let's put this on a graph right here. Let's make a 3-dimensional graph, right? Where we have, you know, the x plane, the y plane, and the z plane, right? Let's call this space. And you know, since we're talking about a 3-dimensional space, let's call this space too, right? And then we'll call this axis time. I'm doing this for simplicity's sake. I'm sure that, you know, whatever, you know how there's like multiple like flavors for quarks and so on and so forth compared to charge. Let's just go ahead and use charges for simplistic sake for understanding this model right here. All right, so we'll say that, you know, this is positive. You know, over here we have negative, negative, positive, positive, negative, right? So what this means is that c equals 0 is at this central axis here, existing within, because this doesn't have any mass, right? So it doesn't exist outwards into space at all. And it doesn't experience time, so it doesn't have to go travel outwards in any of these axes. So it exists in a multi simultaneous state between all of these. So check this out. This is a negative time, negative space, positive space parity on this side over here, right? And then we can move over to its cousin on this side, which is still above this axis. And then we can say that to the right, this would be a positive time, positive space. I'm sorry, a negative time, a positive space on the right-hand side of this. And then on this very opposite side here, and it's really hard because it's like 3D spatial logic. I guess it's hard for me to kind of visualize it mentally. Then over here you have obviously positive space, positive time, and negative space because we're in the 3-dimensional axis, right? But check this out. This is the Big Bang. This is where it all kind of comes together, right? This is the Big Bang. And when you and this is actually where we are. We are in this axis. We're in a positive space, negative time axis. This is our universe. This is where we are going. We are experiencing a negative flow state of time. However, we're still experiencing that. We're still experiencing it like this. We still experience it forward. It doesn't change depending on your parity, right? And so yeah, this explains, I don't really know how to go further. There's 8 of these universes. We have, so what this means is as you extend outwards into the space-time axis, you gain mass. You become these objects of mass. But because light is this kind of thing that exists everywhere, right? The Big Bang is everywhere all at once. This point is also everywhere all at once. And so this becomes like a sheet, if you will. It's a multi-dimensional sheet which within this mass exists and bends. And then when you have things like a black hole, right, you have these huge, gigantic dark matters, whatever, condensed matter. It literally bends these axes of space going back into the time, but it goes all the way back here into this axis, and then simultaneously on every axis there's another black hole that connects all of them together, right? Kind of like a pin or something, whatever you want to call it. So yeah, And so you think, okay, well, how can he say that we live in this negative time axis? How is that possible? That our universe is negative time when I experience a forward moving time, right? We sit here and say, well, our clock is moving like this, right? And that's what we arbitrarily call as a forward momentum of time. But you know what but if it doesn't matter how you flip the paper or even you invert the clock, as long as the clock is ticking in a direction, you can consider that forward momentum. You see what I'm saying? So as we're moving this way, entropy increases, but that's just the reversal of the time arrow. So again, how can we check this? I can't remember the exact researchers that did this, so forgive me, and I give all credit to them who did this. I think they took cobalt-60 atoms and they froze it down, watched how these cobalt atoms, right, these cobalt atoms spat out electrons. And now here's the catch. If the universe was not this symmetrical model that I'm telling you about, there would be no preference for a type of spin, right? There would be no preference. There'd be none of that at all. There would just be random chaotic spin everywhere. Well, it turns out that these cobalt atoms spat out left-handed preference spin electrons. And that just goes to show you that we're over here on the left side of the graph. We're not over here on the right side of the graph, where this side has a preference for right-handed spin, while our universe has a preference for left-handed. So we're here on this left negative space, positive space, negative time universe. There you have it, folks. We live in a negative time universe.